Question number 1. Let A and B be even such that probability of A is 0.5, probability B is 0.4, and their union is 0.6. That means they can happen together. So find A given B. So for the formula for A given B is probability of A intersection B divided by probability of B. We have probability of B here 0.4, but we don't have intersection, and this intersection we'll get from the equation, which is probability, this is a formula. So A union B is equal to probability of A plus probability of B minus probability of A intersection B. And we know everything here. Probability of A union B is 0.6. Probability of A is 0.5. Probability of B is 0.4 minus probability of A intersection B, which we need to find out. So let's bring this to the other side. 0.6 minus 0.5 minus 0.4 is equal to minus probability of A intersection B, and this will be how much? 1. 0.1 minus 0.4 will be minus 0.3 minus A intersection B. Both are negative, make them positive. So we got the intersection of A and B, the probability is 0.3, and that's what we will use here. 0.3 divided by probability of B is 0.4, and which is 3 over 4. Or you can write in decimal also 0.75. This is the answer of question number 1. Moving on to question number 2. Show that 2n minus 1 square, 2n plus 1 whole square is equal to 8n square plus 2, where n is an element of integers. So n are integers. So we should know here that whenever there is 2n minus 1 or 2n plus 1, they mean these numbers are odd numbers. I'm mentioning this because they are written 2 consecutive, and that is not visible here. I'm sure it is odd. 2 consecutive odd integers, because the difference between 2n minus 1 and 2n plus 1, if you subtract one from the other, 2n obviously plus 1 will be more. If you subtract them, it will be this and this will cancel, but 1 minus minus 1 will be 2. Difference is 2. And 2n plus 1 is always an odd number if n is an integer. So I've completed that because it is not printed here. So let's show it. A part. We will expand the brackets here. So we know an identity that A minus B square is A square plus B square minus 2AB, right? And that's what 2n will be A for me, 1 will be B. So A square plus B square minus 2AB, and mind it, we can't use a calculator in this, so we will not even touch it. 2n, here it is A plus B, so if it is A plus B, the identity changes to B with 2AB. So 2n square plus 1 square plus 2 times 2n and 1. So this one and this one are exactly same but opposite sign. We can cancel them, no need to expand that one. So it will be how much? 4n square, both of them squared, 2 as well as n, plus 1 plus this also 4n square plus 1. So 4n square plus 4n square is 8n square, and 1 plus 1 is 2, and this is what our HS right hand side of the equation was. Can you see? Hence, or otherwise, prove that the sum of the squares of 2 consecutive odd integers is even. We have to prove that this is even. So B, let's take 2 common out of this, right? So what is left in the first part? 4n square. And what is left from the second term? Just 1, because 2 is out, so 2 times 1 is 2. If I expand this, I'll get back the same expression again. So no matter what value of n I keep, right, it will always be a multiple of 2 because 2 is outside here. So we can write, since 2 is a factor of 8n square plus 2, the sum of the two consecutive odd integers 2n plus 1, 2 minus 1 and 2n plus 1 will be divisible by 2, hence an even integer. Question 3. They have given the differentiated version of a function and they're saying that f0 is 5. Let's interpret this, what they mean to say. f0 is 5 means when x is 0, y or fx is 5. This is what it means. So from the first derivative we have to find the equation of the function. That means we'll have to integrate the derivative part. So we will do with respect to x on both sides and here also. Since integration and derivative are opposite of each other, they cancel out and we are just left with fx, whose equation we need to find by integrating this right side. Now on the right side you can see that we have a square root at the denominator. It's a rational kind of function and we don't have any kind of quotient rule like we have for differentiation, for integration. We don't have any such thing. So what will we do? We will do the substitution method. So let's assume 2x square plus 1, which is the denominator without square root, is t. Okay, so dt over dx, if I differentiate this with respect to x, dt over dx will be just 4x. Yeah, the differentiation of this will be 4x. Differentiation of 1 will be 0, so just 4x. Look at the numerator here, it is 8x, double of 4x. Can I write like this? 2 outside and 4x inside. 2x square plus 1 dx. I have not changed the question itself, I have just changed the look. I have broken 8 into 2 parts, 2 outside and 4x inside, so that this 4x and dx, if I multiply here, dt will be 4x dx, and that's what I want. 4x dx will be the dt, so it becomes 2 dt. And 2x square plus 1, we have already assumed it as t, so it will be square root t. And now our question changes and we will do it accordingly. So I can write 1 over square root t as t to the power minus half dt. Right? And to integrate any simple exponential term, we just do what? T to the power exponent plus 1 divide by same exponent plus 1, and 2 is already here, plus c. This will be the fx, not fx right now, but it is in terms of x, so I will just write it later. Okay, so what does this become? This becomes 2t to the power minus half plus 1 will be power half over power half. No, denominator is half, not power. So denominator of a denominator is numerator, so this 2 will be the numerator here and become multiply with this 2. So what do we get here? We get 4t to the power half, or which you can write as square root t. Divide by 1, there is no need. So finally we get fx, it was plus c also, fx equal to, bring back the value of t now, square 4 square root 2x square plus 1 plus c, and this is the equation of fx, However, without finding the value of c, it is not complete. So this fact will help us to find c. So fx is 5 when x is 0. So 2, 0 plus 1 plus c. So 5 equal to 4, this is 0. Square root of 1 will be 1, so 4 times 1 plus c. So c comes out to be 5 minus this 4, 1. So your final equation will be fx equal to 4 square root 2x square plus 1, which was already with us, plus c, which is 1. This is the final answer. Alrighty, let's go to question number 4, which is here. The following diagram shows the graph of y equal to fx. It is different fx because different question. The graph has an horizontal asymptote at y equal to -1. We can see that here. The asymptote word is not written here. We can write it here. The graph crosses the x-axis at x equal to -1 and 1. So this and this, okay. And the y-axis at 2. We can see at 2. So let's write 2. Okay. On the following set of axes, sketch the graph of first the whole fx is squared and then plus 1, clearly showing any asymptote with their equations and coordinates of any local maxima or minima. Alright, since it is squared, that means the negative part will become positive, isn't it? So let's make a table and try to write the specific values for specific places. So x and fx, and then it will be fx square plus 1. First point, do we know something here? We don't know anything here. So we know only -1. When x is -1, fx is 0. And then clearly we know here when x is 0, fx is 2. And then when it is +1, again it is 0. And let's say that when it is infinity, positive or negative infinity, in both cases it is almost -1, okay, approaching -1. Okay, so let's try to find fx square plus 1. So we'll fx this square, this one first, which is 0 square plus 1 will be 1. 2 square plus 1 will be 5. 0 square plus 1 will be 1 again. And infinity square will be infinity. That means this x direction and y direction infinity. Whatever we square and we add +1, -1 square will be +1 and +1. That means our graph will end at y equal to 2 in both directions. So y is equal to 2 here, so it will be somewhere going here, not exactly 2 but approaching this. Alright, then we have -1 and 1. -1 and 1 is here. Then we have 0 and 5. Add 0, it will be 5. And +1 again, it will be 1. And it will reach there. So we can see some kind of the format now. So since this is increasing graph here, but the value of -x is decreasing, that means their square will also decrease. So our graph will be somewhere not equal to 2 but reach here. Then we have to go at 5. So as the number is increasing, their square will also increase very fast. So I hope this one is better. Now let's see if we have fulfilled everything. On the following set of axes, sketch the graph of this. We have done that, clearly showing any asymptote. There will be an asymptote at y equal to 2. It will not be touching it. It will be just going towards 2. Okay. With their equations. Okay. So equation of this one is y equal to 2. Okay. And the coordinates of any local maxima or minima. So let me write the coordinates of maximum here is 0, 5. Local minimum here is 1, 1, and -1, 1. And we have already written the equation of the asymptote. Every requirement is fulfilled. Question 5. The function f and g are defined as these two. Show that g of fx is 2x plus 1. G of fx can also be written as g of fx. That means inside g we will write fx. So let's write it as g, and what was fx? Fx is this, x plus 3 over 4. And what does this mean? Whatever is x in g, replace that by this expression. So we have 8x plus 5, that's what we will do. 8, and in place of x, it will be x plus 3 over 4 plus 5. This 4 and this 8 will cancel out because 8 multiplies only with numerator, never with denominator in a multiplication when a complete integer multiplies with a rational part. So this will be 2, this will be 1. So what are we left with? 2x plus 3 plus 5, which is 2x plus 6 plus 5, and that is 2x plus 11. We have shown that here. Okay, let's move it this way. Okay, what is b part? Given that g of f inverse a, okay, g of f inverse a is 4. So let's do it the similar way. B. So we already know g of f x is 2x plus 11, right? They're asking us g of f inverse a equal to 4. This is what they've given us, and they're asking us what is a. Basically, we have to find the inverse of this one. So let's call this g of f as some other function. Let's say k. Kx is 2x plus 1. 11 rather, 2x plus 11. So let's find inverse of this. So for inverse, first we have to write this as y equal to 2x plus 11. And to write inverse, we have to substitute, rather exchange the places of y and x. It becomes x equal to 2y plus 11, which will be x minus 11 equal to 2y, and divide both sides by 2. So y is x minus 11 over 2, which is the inverse of k now. K inverse x equal to x minus 11 over 2, and that's what we will write here now. G of f inverse, let's say a, if they're saying a, is a minus 11 over 2. Yeah, because this was g of f inverse, and they said it is equal to 4. So 2 multiplies with 4, so a minus 11 equal to 8. A is 8 plus 11, which is 19. Question number 6. Show that this log base 9 is equal to this log base 3. So let's focus on the left hand side. Whenever we want to change the base, first of all, forcibly change the base. That means whatever is base 9, make it base 3. Okay, now we have to compensate. We just can't just simply change it. We have to compensate it by writing the same base, new base we have written, log base 3, and the old base will become the number with that base. Since we cannot use calculator, that means this we have to evaluate ourselves. And how do we evaluate that? What exponent of 3 is 9? That's how we evaluate log. So let me write the numerator as it is, cos 2x plus 2. And the exponent of 3 is 2. 3 square is 9. So what exponent of 3 is 9? 2. So this becomes 2. We can write this as 1 over 2 log base 3 cos 2x plus 2. Yeah? And now this becomes the coefficient. We can take coefficient and make it the exponent of the content of log, which is this. Component became the exponent. So now square root means power half means a square root. So we can write this as log base 3 square root cos 2x plus 2. And this is what is the RHS. This is what they wanted us to show. Alright. B part says hence or otherwise solve this. Okay, why otherwise? We'll use the same fact because the right hand side of this one, this is equation now. This is not identity, okay? This is the left hand side which was here. That means in place of this, we can write what we just got from the A part. So left hand side of the equation is log base 3 2 sine x in B part. Now right hand side will become what we just got, log base 3 square root cos 2x plus 2. This is what we got. And why did I do that? Because this was base 9, this was base 3, we can't equate. But now we have log base 3, we can equate the logs, log parts, means the contents inside. Okay. So 2 sine x is inside log here, and square root cos 2x plus 2 is on the right side. Now logs are gone. Now we have to get rid of this square root. Let's square here and square here. We get 4 sine square x equal to, this is square root and square cancel. That was the purpose, cos 2x plus 2. Now this is cos 2x, this is sine square x. But the best thing about cos 2x is that it can be converted to sine square x. If you look at your formula sheets, you will get the identity I'm going to use now. So 4 sine square x remains 4 sine square x, but this one is equal to 1 minus 2 sine square x. If you can look at the formula sheet, you will find it. And plus 2 is plus 2. Let's combine the sine squares. So it will be 4 sine square x plus 2 sine square x equal to 1 plus 2, 3. 4 plus 2, 6 sine square x is equal to 3, divide both sides by 6 so that we get rid of this 6 here, which is half. Sine square x is equal to half. But when they say solve, they mean find the value of x, not sine x or sine square x. That means we have to go to sine x first and then find the value of x. Square root both sides again to get rid of the square. Sine x equal to square root of 1 is 1 and square root of 2 is square root 2, and because plus and minus both are the square roots of half, this will be the 1. Now if you look at your question, they have already said that the value of x is between 0 and pi by 2. That means the x is in the first quadrant of the angles. This is 0, this is pi by 2, this is pi, this is 3 pi by 2. So we want only first quadrant because 0 to pi by 2 is here. And here sine is positive, so negative is of no use. And x is equal to sine inverse 1 over square root 2. You could have used your calculator, but it is not allowed in this paper 1. So we should know that sine 45 or pi by 4 is 1 over square root 2. So this will be the answer of this question B part. Moving on to question number 7. A continuous random variable x is continuous random variable x has the probability density. Okay, function f is given by this. Alright, so it is this for from 0 to 6 and otherwise it is 0. There is no possibility beyond this. Okay, find the probability between 0 and 3 both included. So first of all we should understand what it means. Suppose this is the graph of the probability, right? So from 0 to 6, the sum of this whole thing is something, but the density, this function, this fx equal to this shows one of these lines. This line, if I take and substitute the whatever is the value here is will give me the probability at that particular point. But since we want from 0 to 3 and it's a continuous graph, that means we have millions and millions of lines in between which we cannot add easily. So the best thing is that we integrate the function and we'll get the sum of all the y values from 0 to suppose 3 is here. This whole thing we'll get by integrating this. So this 0 is useless because 0 to 3 is all here. So we'll integrate this one from 0 to 3 and write pi x over 36 sine angle is pi x over 6. Okay, so we can see here that there is a variable outside and there is a trigonometric variable also. That means we can use the integration by parts, but it's difficult to do this way. So what will I do? This angle is pi x by 6. So let's assume that t is pi x over 6. So what will be dt over dx? Let's look at that one first. Dt over dx, differentiated this with respect to x. So the only x will be differentiated, which is 1. So we get pi over 6 is dt over dx. So this means that dt will be pi over 6 dx. Okay, so we have pi here, we have 36 here. Let's break it. So 0 to 3, we want pi over 6 alone, and what will be left? X over 6 and sine pi x over 6 dx. So this will become part of dt, this dx and pi over 6, because pi over 6 dx is dt. So let's write dt in place of this. Sine, and this angle we have already assumed as t, sine t. Pi over 6. So if I say pi over 6, or sorry, x over 6, it is x over 6. X over 6. This one, what can I write? X over 6 equal to x over 6 will be t over pi. Yeah, if I cross multiply this, bring this pi here. So x over 6 will be t over pi. So in place of x over 6, I can write t over pi, and dt, this has been taken care of, this has been taken care of, this has been taken care of, and this becomes our new integration. But I'll have to change the limits of integration also. So let's say 0 first. So I'll use this relationship again. When x is 0, so I'll put t will be pi times 0 over 6, which is 0. So lower limit remains 0. When t is 3, so sorry, not t, x is 3, right? Okay, x is 3, so t becomes pi times 3 over 6, cancel out 2. So it is pi over 2. The limit will be pi over 2 here. Okay, now it becomes easy to integrate. Pi is a constant, keep it out. So our new integration will be 0 to pi by 2, 1 over pi I'll keep out, and we are left with t sine t dt. That's simple now. So now this is the algebraic part, this is trigonometric part. If we use our sequence liet, so we have a and t. A is u and t becomes v prime. Okay. So for doing by parts, we know that u v prime integration, which is this is u us, this is u for us, and this is v prime, is uv minus integration of u prime v. So in place of this whole, we can write uv first. So what is u for us? T. What is v? We'll have to integrate this so that we can get here. So v prime is sine t. This is what we have assumed. So we'll integrate both of them. So v will be integration of sine t, which is minus cos t. Okay, so minus cos t minus integration of u prime. So integration of t, not integration, differentiation of t. So u is t, so u prime will be 1. So no need to write anything here, u prime is 1. V, we just found out v is minus cos t dt. Alright, so this becomes minus t cos t, and please keep in mind this 1 over pi is still out. We are not taking care of this, okay? We'll take care of that at the last stage. Alright, plus integration of cos t, because this is plus cos t round, this negative and this negative both become positive. Integration of cos t is positive sine t plus c, and let's put back our 1 over pi in front, and it will be from 0 to pi over 2. Let's continue here. So 1 over pi, and substitute pi by 2 first, so it will be minus pi by 2 cos pi by 2 plus sine pi by 2 plus c. If you don't write c, it's okay, but I'm writing it to cancel it later on. Minus again 1 over pi 0. Okay, 0 times cos 0 will be 0, so no need to write it. Then sine 0, sine 0 is 0, right? Plus 0 and plus c. C and c will cancel out. Both of them have 1 over pi, so they will cancel out. That means there is nothing here. Yeah, there's nothing here. 0 plus 0 is 0, multiplied by 1 by pi, gone. Only this thing is left, which is 1 over pi minus pi by 2. Cos pi by 2 is also 0, so this is also gone. Sine pi by 2. Sine pi by 2 is 1. So answer is just 1 over pi. What are they saying? Probability, right? 1 over pi. So probability of 0 and 3, it is between 0 and 3, is 1 over pi. That's the final answer. Great. Let's go to the next question, number 8. The plane pi has Cartesian equation given this, okay. The line L has this equation, which has mu a parameter and p a variable, constant, right? Both are real numbers, okay. The acute angle between the line L and the plane is 30 degrees. Okay, let's try to visualize this. This is the plane. It will have a normal to it, okay, which is 90 degree. And since they have given the equation 2, 1, 2, they become the direction vectors of the normal. 2, 1, 2. They are, this is the vector from the plane which is perpendicular to the plane. Alright. The line is making 30 degrees with the plane, not with the normal, right? Line and plane, okay. So let's draw that. This is coming here and this is 30 degrees. That means it is making an angle of 60 degrees with the normal, because total is 90 degree. Got it? Find the possible values of P. Okay, so we know that the vector in this direction is this part. This is a point, so we don't look at this. This is the vector 1 minus 2 P. So there are two vectors 2, 1, 2 and 1 minus 2 P, and the angle between them is 60 degrees. We can use the dot product or scalar product. We know that A dot B is the magnitude of A, magnitude of B, cos of the angle between them. All right. So in this case, let's take this as A, 2, 1, 2. Dot 1 minus 2 P is equal to magnitude of A. So magnitude of A will be the magnitude of 2, 1, 2. It will be 2 square plus 1 square plus 2 square multiplied by the magnitude of B, which will be square root 1 square plus minus 2 square plus P square. And the angle between them is 60 degrees. We just found out cos 60 degrees. So let's do the dot product first. In dot product, we multiply the x component with x, y with y, z with z. So 2 times 1 is 2. 1 times minus 2, 2 times P, 2P, equal to 4 plus 1, 5 plus 4, 9. Square root 9 is 3. Then we have 1 plus positive 4, 5 plus P square, and square root is still there. Cos 60, you should know that the value of cos 60 is half. Okay, 2 and minus 2 cancel. 2P equal to 3 and 2, 3 over 2 square root 5 plus P square, and now we can find P by squaring both sides. Let's square this and square both sides. So we get 4P square on the left. This will be 9 over 4. And this will become complete 5 plus P square, because square root and square will get cancelled out. So cross multiply by 4 here, multiply by 4 here, so that this is gone. 16P square equal to 9 times 5, 45 plus 9 P square. Okay. Let's bring this 9 to the left side. 16P square minus 9P square equal to 45. 7 P square equal to 45. P square is 45 divided by 7. And P's possible values are square root 45 over 7. Bring on number 9. Okay, here is the one. The function f is defined by this, where x is any real number. We can see that in the graph. The graph is given. Find the largest value of a such that f has an inverse function. Okay, so we should know that for an inverse to be possible, okay, the original function has to be 1 to 1. Okay, every x should have one y, every y should have one x. But here we can see, if I take this minus 2, we can see that 2 x's has 1 y minus 2. Right? This is not 1 to 1. So they're asking us to erase a part of this particular graph so that it becomes 1 to 1. Okay, so if I erase this part, this one, this part will become 1 to 1 because there is no second y has been eliminated. Or if I erase this one, the remaining part, the second part will become 1 to 1, and both the ones will work. But they have given us a hint. They're asking us the largest value. If I erase this part, the lower part, this particular number will become the lowest value. But we want largest. That means this particular part, which is on the right side, higher, is to be deleted so that this becomes our largest value, this one. Okay. Now, how to find that largest value? We can see that it's a turning point and it's a local minimum. So if we find the x coordinate of local minimum or turning point, we'll get it. For local minimum, we should have the first derivative equal to 0. So we will differentiate this, the main function, which will give us derivative. So the derivative of e to power 2x will be 2 e to the power 2x. Derivative minus 6 is a constant multiplying, we will not touch it. E to the power x, the derivative of e to the power x is e to the power x only, and plus 5, its derivative will be 0. So this is the one which should be equal to 0. That will give us an x coordinate of the turning point. Okay. Both of them have e to the power x, so we can take e to the power x common, and 2 and 6, they have 2 common. So let's take 2 also common. So what is left here? 2 is out, e to the power x out from the e to the power 2x, so e to the power x is left, 1. From 6, 2 is out, so 3 is left, and e to the power x is already out, equal to 0. Whenever you have such a situation, always factor so that you can get your answer. So we'll have two answers here, 2 e to the power x equal to 0 or e to the power x minus 3 equal to 0. Okay, we can get rid of 2 also. So e to the power x is equal to 0, which is not possible. If you know e to the power x graph, it will be something like this. For no value of x, the y value is 0. So this is not possible. Reject this answer. Now here e to the power x is equal to 3, and to remove e, we applied ln to the other side. So e equal to ln 3. Is it making sense? Let me put in my calculator. Ln 3 is 1.09 something. And this is 1. It is little right of 1. That is okay. Yes, this is correct. So question is, find the largest value of a such that f has an inverse function. That value is a equal to ln 3. Okay, B part, for this value of a, okay, that means this graph, this particular graph, find an expression f inverse x first, stating its domain. Okay, so first we have to find the inverse. So let me go back to that one. Okay, so y, it was, the original function was what? Let me write here, fx was e to the power 2x minus 6 e to the power x plus 5. So we have to find the inverse of this first. Okay, so it can be written as y equal to e to the power 2x minus 6 e to the power x plus 5. It looks like a quadratic, so we can convert this into completing the square method of quadratic function. I think that will work here. So let's write here. Let me assume that e to the power x is equal to m. So that will help. Y equal to m square. E to the power 2x can be written as m minus 6m plus 5. So how do I complete the square? It will be m square minus 6m plus half of 6 is 3. 3 square plus 5 minus, I added 9 here, so I have to subtract 9, isn't it? Yep. So m square, not m square, So this will be m, this sign minus this 3 square and minus 4, that is y. So this m was for simplicity. Let's bring back e to power x. Y equal to e to power x minus 3 square minus 4. Let's get this minus 4 to the left side. Y plus 4 equal to e to power x minus 3 square. Mind it, our job is to get to make this x the subject, then only it will become inverse. So let me start the inverse process now. In inverse process, y becomes x and x becomes y. So square root this, square root this also. So we get what? This is square and square root cancel out. Square root x plus 4 equal to e to the power y minus 3. And we will have plus and minus for this square root. Alright, so what do we get? Plus minus square root x plus 4 equal to e to the power y minus 3. Let's bring this 3 to the left side. 3 plus minus square root x plus 4 equal to e to the power y. And if we want to isolate y here, the opposite side will become natural log of 3 plus minus square root x plus 4. If I keep both plus and minus, it will become it will not remain one-to-one function. That means one of them have to go. Now this is natural log. Let's write two of them. 3 plus square root x plus 4 and 3 minus square root x plus 4. So which one works out of these two? If you remember, this y is the inverse we are trying to find out, right? And f inverse x is nothing but x in the original function, which is here. It was ln 3 if you remember, right? Which one will give you ln 3 and less? Because it is ln 3 here in this function. This, if you look at the graph, this is ln 3. This is what we found. We want less than ln 3, and this will add to ln 3 because this is the natural log in front, and this will be less than ln 3. That means this one is the one which is matching with our given function. So we will isolate this one, and this is what we will write. So it will be 3 minus square root x plus 4. Additionally, they have asked us to find the domain of the new inverse function, which will be the range of the previous function. Question number 10. Let fx equal to this, where x is greater than 0, only positive number, and it's a real number. Okay, show that f prime x, the differentiation of this is this. Okay, let's do that one. So fx is equal to ln 5x over kx, and for finding the differentiation of this, we will have to use quotient rule. In quotient rule, if you remember, u over v prime is v square u prime v minus u v prime. Yeah, that's what we're going to do. So v square first, the denominator gets squared. Okay, and then we write the differentiation of this one, ln 5x, which will be 1 over 5x times the differentiation of what is inside ln, which is 5, multiplied by v. V is kx. Okay, then minus, then we have u, which is the numerator, and then v prime, the differentiation of the denominator kx. So the differentiation of kx will be just k. So we can cancel 5 and 5 here, x and x here. So it will be, the denominator will be k square x square, and what will be the numerator here? Only k is left here. Yes, only k. Minus, here it will be k ln 5 x. Okay, in these two terms we can see that k is common, so let's take k common. We are left with 1 minus ln 5x over k square x square. This k can cancel with one of the k's. 1 minus ln 5x over k x square, and that is what they are asking us to show in A part. In B part, they say the graph f has exactly one maximum point, P. Yeah, we can see the graph they have drawn here, and it's a maximum point. The gradient at maximum point is 0. That means gradient, which is the first derivative, should be equal to 0, and this is first derivative. We just found out. So for B part, this first derivative 1 minus ln 5x over kx square will be equal to 0. Kx square will go and multiply with 0, it vanishes. We are left with only 1 minus ln 5x equal to 0. So let's take ln 5x to the right side. It becomes positive like this. 1. What if I want to remove this ln from this side? It will become e to the power 1 is equal to 5x, right? And then if I divide both sides by 5, we get e over 5, or if you want to write 1 over 5 e. This is the x coordinate they are asking for P. This coordinate here is 1 over 5 e. Next, the second derivative is this. They have done it, they are not asking us to do it, they are saving our time. The graph of f has exactly one point of inflection. Okay, point of inflection is the one where the concavity changes. Can you see? This is concave down, something like this, opening down. But after Q, it is kind of opening up. So wherever the concavity changes, that's called point of inflection. And what is special about point of inflection? At point of inflection, second derivative is 0 because the rate of change is changing. Okay, and that's why they have already given a second derivative. We'll make it equal to 0. And what are they saying? Show that the x coordinate. So they are asking again the x coordinate. By the similar method, we will find the x coordinate of point of inflection. 2 ln 5x minus 3 over kx cube, right? Yeah, equal to 0. So again, this goes and multiplies with 0, gone. So we are left with what? 2 ln 5x minus 3 equal to 0. 2 ln 5x equal to 3. So we will make some space here and ln 5x. Divide both sides by 2. So this 2 goes, ln 5x is equal to 3 over 2, and again I want to remove this ln, so the other part will become e to the power 3 over 2. Divide again by 5. So 5 and 5 cancel, x is equal to 1 over 5. What are they saying? 1 over 5 or divided by 5? Let's see. Yeah, 1 over 5 e to the power 3 over 2. This is what we will write now. So e to the power 3 over 2 and 1 over 5. In front of that, we have shown that. Okay. What next? The region R is enclosed by f graph. Okay, done. This is the graph f. Okay, x-axis, this one. The vertical lines through the points P and Q, this and this. Yeah, so this is the region R. Okay. What are they saying? Given that the area of R is 3, they're giving us the area. Okay, find the value of k. All right. So to find the area under a curve from two starting and ending points P and Q, so x coordinate here is 1 over 5 e. We already know the x coordinate here is 1 over 5 e to the power 3 over 2, right? So for D part, we'll have to find area under curve from 1 over 5e to 1 over 5 e to the power 3 over 2. Okay. Okay, so let me not look at the limits right now, and this k also. Can we write 1 over k ln 5x? Oh, let me write 1 over x separate also. Now, if I assume ln 5x is equal to t, then dt over dx will be the differentiation of this, which is again 1 over 5x times 5. 5 and 5 cancel, 1 over x. That means dt will be 1 over x dx. And in our question we have 1 over x dx. And we have ln 5 also. So it becomes 1 over k t dt. Yeah? And integration of t is t square over 2 plus c. 1 over k. This is the integration. And now we will bring back everything we assumed. We assumed ln 5x. Yeah? So we'll write ln 5x square over 2 plus c, and let's bring back the limits we had. 1 over 5 e and 1 over 5 e to power 3 over 2. Keep in mind, this square is over whole ln x, not over 5x. So we can't bring it in front like we do for normal logarithms. Okay, so let's substitute them now. So they've given that this is equal to 3. In the question they said the area under that curve is 3. So let's bring 3 here now. 3 equal to 1 over k. So ln 5x, let's put this one first. So ln 5x, x is 1 over 5 e to power 3 over 2. Rather we'll have to give the smallest bracket for this, and this is squared over 2 plus c minus ln 5 1 over 5 just e, okay, and squared over 2 minus c. This plus c and minus c cancel out. That is the first thing we should do. If you don't write plus c or minus c, that is also okay, no problem about that. Okay, so 3 is equal to 1 over k. 5 and 5 cancel. It is ln e now. Ln and e are inverse of each other, so it becomes just 3 over 2. 3 over 2, and there is divided by 2 already. No, we have to square also. There is a square here. So 3 over 2 squared over 2 minus. Here also 5 and 5 cancel. Ln and e neutralize each other. So we are left with just 1. So 1 square over 2. Okay, can we change the places of this k and 3 by cross multiplication? K equal to 1 over 3, 9 over 4 over 2. We'll make it 4 times 2, 8. 9 over 8 minus 1 over 2. So the LCM is 8 here, so we multiply here by 4, multiply here by 4. K equal to 1 over 3, 9 minus 4, 5 over 8. So it comes out to 5 over 24. That is the value of k. Question 11. Express minus 3 plus square root 3i in form of r e to power I theta. R e to power I theta. This is what we have to express this as. R is greater than 0. It's a positive number. And theta is between minus pi and pi. Okay, that makes sense. So let's visualize this on Argand diagram. The real part is negative 3. 1, 2, 3. This is real part. And the imaginary part is square root 3 positive. So it will be somewhere one point between 1 and 2, right? Somewhere here. So this one is the complex number they're talking about, and we have to find first the modulus r and then theta argument of this complex number. r will be square root and minus 3 square, the real part square, plus imaginary part square. So it will be how much? 9 plus 3, which is square root 12. What about this theta? We know this is minus 3. So this length is 3 and this length is square root 3. To find the argument theta, let's name this as alpha. So in this triangle, tan alpha will be opposite over adjacent. I'm taking the length, right? So it is alpha equal to tan inverse square root 3 over 3, which is pi over 6. So this is pi over 6. So we can find theta now. Theta will be pi minus pi by 6, which is 5 pi over 6. Okay. So we got r, we got theta. We can write the answer of A. It will be square root 12, which is r, then e to the power I and 5 pi by 6. That is the answer of A part. Let the roots of z cube be u, v and w. So z cube is this minus the one we got earlier. In place of minus 3 plus square root 3i, we can write this because that's what it is equal to. So let's write z cube is equal to negative 3 plus square root 3i, that is given. We can write this as equal to square root 12 e to the power I 5 pi over 6. Okay. Find u, v and w expressing your answer in the form of this. That means this is of no use. We will use just z cube and this. R has to be greater than 0. Okay, it is a different r. Okay, the format is r e to the power I theta. This is not same r, okay? And its theta has to be between minus pi and pi. Okay. So what situation we have here? Z cube is square root 12. In place of square root, let me write 12 to the power half. That will help better. And e to the power I 5 pi by 6. Now, to find z, the root, we'll cube root it. 1 over 3 power here and 1 over 3 power on this side also. So 3 and 1 over 3 cancel. Z will be 12 to the power half, and there's another power, so it will become 12 to the power 1/6. Okay, and then e to the power, it will multiply with this one, it will become I 5 pi over 18. But it is just one answer. It must have 3 roots. This is just one of the roots. So let's call it Z1. Or rather not Z1, which is u, v, w they have given, so u. What about v? For v, we know, if I show you here, this is z cube, right? This one. How about this? Can I have that this will be after I start from here and reach here, I go 2 pi more and I reach back here. That will give us v. So what we're going to do now, that in place of 5 pi plus 6, let me write here. What will I write? 12 to the power half e to the power I 5 pi by 6. This was the one. I will add 2 pi to this. So this will give me the second value of z cube, and then I have to give it power 1/3, just like this, and that's how it will be. It will become again 12 to the power 1/6 as usual, like before, but the new one will be I 5 pi by 6. Rather, let me add them. 6 plus 6 times 2 is 12, 12 plus 5 17. So let me write straight away 17 pi by 6. Okay, so here it will become 17 pi by 6 and multiplied by 3, so it becomes times 3 in denominator. So v comes out to be 12 1 to the power 1 over 6 e to the power I 17 pi over 18, which is very close to pi. they have given us a range minus pi to plus pi. That means we are already near to pi. So for the third one, which is w, we will not go beyond this. Otherwise, we could have added 2 pi, and in place of 2 pi, we will write 4 pi and get the next one. But because this is very, very close to pi, what will we do? We will go backwards. So like here, I will go in opposite direction. This one, which will be minus 2 pi from the 5 pi over 6, this the one we got here. So this is what we'll do. 12 to the power 1/2 ei 5 pi by 6 minus 2 pi, and then we have to give 1/3 to 1. So we got u here, we get v here, and now we will find w this way. So let me do it here. 1/6 power to the 12, and then e 6 times 2 is 12, and 5 minus 12 is minus 7 I. Let me put negative first. I 7 pi over 12, which makes 18 rather, because of this 3 multiplied with 6, it becomes 18. And see, it is 7 pi over 12 is in negative direction, which is all correct, right? Because they said theta is between minus pi, and all three angles are there. So this is u, this is v, and this is w. We got all three. Let's see what is the next part. On Argand diagram, show these three and represent by u, v, w points and find the area of the triangle. They are making us difficult and difficult. Okay, so let me do it here. Okay, the first one is 12 1/6, whatever that is. It will be less than 1, I think, or a little more than 1. Okay, and the angle has to be 5 pi over 18. 5 pi over 18 will be how much? 50 degree. 50 degrees. So somewhere here. Let's say this is u. Its magnitude is 12 1/6, this particular side. Okay, the second one is 17 over pi over 18, almost 180 degrees, 170 degrees in degrees if we run. So this is same magnitude, modulus is same, but angle is 17 pi over 18. So this is also 12 1/6. This is v, and w is in negative direction, 70 degree, almost here. Okay, same magnitude, 12 1/6, and this is w. They're asking us to find the area of this triangle. Since we know that these sides are equal, that means this is an equilateral triangle, and if we find the area of one triangle, let me find the one which is easier. Let's say this is easier. This triangle I find, and I'll multiply this by 3, I'll find the area of the whole triangle. So we know area of a triangle is half AB sine C, where C is the angle between sides A and B. We know side A is this, side B is this, and the angle here we can rewrite. This was 5 pi over 18. This was 7 pi over 18. I'm writing positive because I'm interested in magnitude, not the direction. So 7 plus 5, 12 pi over 18. So this is 2, this is 3. 2 pi over 3, 120 degrees. Okay, we'll use this one. So half A, 12 1/6, 12 1/6, and sine 2 pi over 3. So it becomes half 12 to the power 1/3, right? Yeah, and sine 60 degrees is square root 3/2, right? square root 3 over 2. That's 120 degrees also. It's the second quadrant, sign is positive. Because in second quadrant sign is positive, so we get what? Square root 3 over 4 and then cube root 12. Yeah, this is the area of one triangle. We want the area of the all three triangles. So area of UVW triangle will be 3 times what we got just now, the cube root 12. Okay, let me convert this to decimal if it is needed. By the time I do this, I would request you to subscribe to my channel, like this video, share with your friends, comment if there is any mistake in this, and we can discuss that. And when I use my calculator, I get 2.97. Okay, let's see what is the next part. Find the area. Okay, by considering the sum of the roots, okay, u, v and w, show that this is equal to 0, 5, 18, 7. Yeah, they are exactly what we got. So we'll just do it and see if it is correct. Okay, cos 5 pi by 18 plus cos 17 pi over 18 plus cos 7 pi over 18. This thing is equal to 0. This is what we have to show with the help of the 3 roots, which is u plus v plus w. Okay, for finding the sum of roots, we should know the original equation. So let's see what is it. Z cube equal to minus 3 plus square root 3i. Okay, let me write it here. Z cube equal to negative 3 plus square root 3i. Let's make a cubic equation out of this. Z cube plus there is no z square, so 0 z square I can write, plus there is no z as well, but we have a constant part which is negative positive 3 rather. It will become positive 3 when it goes to the left side, minus square root 3i, and that will be equal to 0. This becomes our cubic equation in which the coefficient of z cube is 1, which is a for us. The coefficient of z square is b, coefficient of z is c, and the constant part is d. They are asking us to take help of this, the sum of the roots. Sum of the roots of any cubic equation is minus b over a. So minus b means minus 0, and that is 0 over 1, which is 0. That means the sum of the roots is definitely 0. And we have to substitute u, v and w now. U was how much? 12 to 1 to 6, 5, 18, yeah, that one. So let's write here 12, 1 over 6 e to the power I 5 pi over 18. Then v is 12, 1/6 e to the power I 17 pi over 18, and then plus w was 12 power 1/6 e to the power I negative I 7 pi over 18. But we have to get answer in terms of cos and sine. This is cos, yeah? That means we have to convert it to modulus and argument format. So let's do this. So 12 1/6 is in common in all of them, so let's keep it out of these 3. Let's convert this one first. It will be cos 5 pi over 18 plus I sine 5 pi over 18 plus this one will be cos 17 pi over 18 plus I sine 17 pi over 18 plus cos negative 7 pi over 18 plus I sine negative 7 pi, not 17, 7 pi over 18. Okay, this is u plus v plus w. When I substituted their value, it was equal to 0. It will be equal to 0. So since let's divide both sides by 12 1 to the power 6 and 12 1 over 6. So this becomes 0, cancels out. So can we connect cos, cos and cos together? Cos 5 pi over 18 plus cos 17 pi over 18 plus cos, here it is negative 7 pi over 18, and if you look at this drawing I've drawn here, the fourth quadrant, it is negative 7 pi over 18. Cos is positive in this quadrant. That means it can be written as cos positive 7 pi over 18. Doesn't matter. It will be positive. So it is equivalent to cos 7 pi over 18. Plus, now the remaining three terms, this and this, they have I. So let's take I and write sine 5 pi over 18 plus, then we have sine 17 pi over 18, and this is negative again, angle, and in fourth quadrant sine is negative. That means this negative can be written in front. So it will become minus sine 7 pi over 18, and this is equal to, let's write 0. It was 0 equal to 0. We can write it 0 plus I0 because there's no real part, there's no imaginary part. And if we compare the real part with real part, that gives our required proof that they wanted. So let me go. This is what we'll get, because this is the real part on the left side, this is the real part. And by considering the sum, we have done show that this is equal to 0, and we have shown that this will be equal to the 0 we have written here, this 0. So shown. That is it. Question number 12. The function f is defined by fx equal to e to the power sine x. Okay. Find the first two derivatives of fx and hence find the Maclaurin series for fx up to the x square. Okay, first of all, let's find the first two derivatives. So first derivative of this will be e to the power anything is the same, e to the power sine x, multiplied by the differentiation of whatever is the exponent. Here the exponent is cos x. So it comes out to be cos x e to the power sine x. Okay, that's the first derivative. Second derivative we have to find out, which will be cos x and e to the power sine x are multiplying. So we'll use product rule in this. So first I will differentiate cos x, which is a negative sine x, but I'll keep sine e to the power sine x untouched, plus cos x remains cos x, and I will differentiate this again, which I got earlier. This is it becomes cos square x because of this cos x, and e to the power sine x. This is second derivative. All right. They're saying first find those two derivatives and Maclaurin series up to x square. Let's go to Maclaurin series. I have that here. So Maclaurin series says, let me copy it here, fx equal to f0 plus x, f first derivative, second derivative, right? So that's what we have to write. So let me write it here. Okay, mx is equal to, first thing is f0 and then x f prime 0. f0 plus x first derivative 0 plus x square over 2 factorial f second derivative 0. We have everything with us? Yes. So let's finish it here. Mx will be f0. So fx is already known to us, this one. So we'll write e to the power sine 0 plus x and f first derivative 0, which is here. Cos 0 is 1 e to the power sine 0. Okay, done. Then x square over 2 factorial. 2 factorial is 2, so let's not write factorial anymore. Second derivative is this big thing. So multiplied by minus sine 0 e to the power sine 0 plus cos square 0 e to the power sine 0. Alright, so what will that be? Sine 0 is 0, so e to the power 0, 1. X is x. Cos 0 is 1, e to the power 0 is 1, so it is just x. Plus x square over 2. Sine 0 is 0, so this whole thing is 0. Cos square 0 will be 1, and this is also 1, so just 1 inside. So what do we get? We get 1 plus x square over 2. This will be the answer of A part. Let's move on to B part. Show that the coefficient of x cube in Maclaurin series for fx is 0. That means, look at the pattern here. This is Maclaurin series here. So what will be the next one? X cube over 3 factorial f third derivative 0. Yeah? So we'll do the same thing again. So for that we need third derivative of this one. So third derivative, and 0 we'll put later, but first find the derivative. Okay, again sin x and e to the power sin x are multiplying, so we'll use product rule in this. So let me differentiate minus sin x first. So it will be minus cos x. E to the power sin x is untouched. And plus or minus, yeah, minus sin x remains minus sin x. E to the power sin x gets differentiated, which is again cos x e to the power sin x, which we got here. Right. Now we have to differentiate cos square x e to the power sin x. So let's differentiate cos square x first. It will be 2 cos x, and then we differentiate cos x, the base, which is negative sin x, right? Negative sin x. And don't touch e to the power sin x. And then we will not touch cos square x, it will remain cos square x, but we will differentiate e to the power sin x, which is cos x e to the power sin x, so it will become cube and then e to the power sin x. We have to show that this third term is 0. Show that the coefficient of x cube in the Maclaurin series is 0. So 3 cannot be 0, this 3. Obviously this has to be 0, then only its coefficient will be 0, and that's what we're going to do now. So it will be minus cos 0 e to the power sine 0 minus sine 0 cos 0 e to the power sine 0 plus 2, rather than minus, it will become minus now because of minus sine x. So minus 2 sine x cos 0 sine 0 e to the power sine 0 plus cos cube 0 e to the power sine 0. This cos 0 is 1. So minus 1 e to the power sine 0 is e to the power 0, because sine 0 is 0. That is 1. So gone. Sine 0 is 0. So this whole thing is gone. Here also we have sine 0. So this whole thing is gone. This will be 1 cube, which is 1 plus 1, and e to power sine 0 is e to power 0, which is 1 again. So 1 minus 1 plus 1, 0. We have shown that the coefficient of x cube is 0. Let's go to C part. Using the Maclaurin series for arc tan x and e to power 3x minus 1. Okay, let me bring down the question, this question, so that it's easy to see, and take the whole thing down. Okay, so what they are saying is use the Maclaurin series for e to arc sine x first. So arc sine x. Let's go back to our Maclaurin series. Arc sine x is x, let me write here, equal to x, okay, minus x cube over 3 plus x5 over 5, okay, minus x cube over 3 plus x to the power 5 over 5, and that continues. All right, e to power 3x, yeah, e to power 3x minus 1. So first of all, let's see what is for e to power x, then we'll go to e to power 3x, which is 1 plus x square over 2 factorial, simple as that. 1 plus x square over 2 factorial plus x cube over 3 factorial. We have to convert it to e to power 3x. That means in place of each x we will write 3x now. So 1 plus 3x plus 3x square over 2. I'm writing just 2 because 2 factorial is 2. 3x cube, 3 factorial is 6, and so on. We got for e to power 3x, but they're saying e to power 3x minus 1. So let's put minus 1 here, minus 1 here. This 1 will cancel. So this is e to power 3x minus 1, got both of them. Okay. Find the Maclaurin series for arc tan. Okay. So arc tan e to power 3x minus 1. So we know arc tan x. Did I write sin x here? That is my mistake. I hope that is what I did. Okay. So what will we do? In each x, in place of x, we will put all of this. Let's start with this x. In place of this x, we will write this whole of it, because e to power 3x minus 1, this is what it is. So 3x plus, let me expand this one, 9x square over 2 plus 27x cube over 6. That is for this x. Should not go beyond cube because they're saying up to including x cube. So let's go to minus x cube now. Minus, and this whole thing cube. 3x plus 9x square over 2 plus 27x cube over 6, and so on, cube over 3. This is what it is, right? This one cube. I will not go to 5 and I will not go beyond this. So it will be plus something like this. So what will that be? 3x plus 9x square over 2. Let's cancel this. This is 3 times 2. 3 times 9 plus 9 over 2x cube. 3 times 2, 6. Okay, by chance same. Okay, minus. Now we have to cube this whole thing. You know that, let me remind you one formula. Let me write somewhere here. Okay, a plus b, just 2 terms. Okay, cube is a cube plus b cube plus 3a square b plus 3ab square. So can you see that this first term is cubed? In this, every term will be cubed, and then we have a combination of the multiplication of any two of the terms, right? So in that case, only 3x will give me a proper cube, x cube. Anything or any combination after that will be more than cube. So there is no need to look at them at all, because this is the only one which is going to give me cube, and that's what I do. So 3 cube is 27 x cube over 3, right? And they say up to x cube, so we have reached up to x cube, and that's it. Let's see if we can combine some of them. Only these two are cubes, so it will be 3x plus 9x square over 2, and these two can be times 3 here, times 3 here, 2 and 2. So it comes out to be 6 here, plus or minus, I don't know yet. Okay, let me write here plus. 9 times 3 is 27 minus 54 plus x cube. Did I x? Okay, this is multiplied by 2. Okay, so finally what answer we are getting? 3x plus 9x square over 2 minus 20. Okay, 27 over 6 can be written as 9 over 2 again, 9 over 2 x cube again. This is the solution of C part. What about D part? Hence or otherwise. Find the limit of fx minus 1. Okay, what was fx? Fx was e to power sine x, which we wrote as Maclaurin series earlier. Let's see what we got there. 1 plus x squared. This is what we got in Maclaurin series. 1 plus x squared. Okay. So let me do D part here. 1 plus x square over 2, and then divide by, and this is fx minus 1, so we will subtract 1 from this, and then we will write arctan x e to power 3x minus 1 here, which we got just now. 3x plus 9x square over 2 minus 9 over 2x cube. Okay, and we have a limit here, x is approaching 0. Okay, so this minus 1 and this 1 cancel out, so we are left with limit x is approaching 0. All of them have x, so we can take x common from this. X 1 plus, out of x square, x is out, so x over 2, just x over 2 over, if I take x common here, 3 is left, then 9 over 2x minus 9 over 2x square, because x is out of these two. Okay, so we are there, almost there. So x and x cancel. We are left with limit x is approaching 0, 1 plus x over 2 divided by 3 plus 9 over 2x minus 9 over 2x. And now we can substitute x equal to 0 in this, because it's approaching 0. So 1 plus 0 over 2, which is 0. 3 plus 0, this was square, 0. Answer is 1 over 3. This is the final answer, and the exam solution is over. Thank you for watching. Please subscribe to this channel if you like this work. I will be answering many more videos, many more questions, papers in next videos. My channel is new. I need your motivation by subscription. Thank you very much.